I'm Mike Peercy. I'm the CTO at Komprise.
Hi, my name is Mohit Dhawan. I'm VP of Engineering, and I've been in the company for since almost beginning, so about 4.5 years, and I've worked with all three of them, actually three founders at Citrix before.
So I'll just start digging into the architecture, and again, it's in three pieces that we're going to go through a Chalk Talk. We'll go through the analytics piece, that is the discovery, the analyzing, the knowing before you act. Then we'll look at the most common action, which is the transparent archiving, the transparent data movement with archive. And then we'll take a look at the cloud data management that we're moving towards. So I'll start by going into the architecture here. And the first component is, what is it that serves up that console? And that is the director. So we'll just show a box here as a director. This can be hosted on the premises of the customer if they want, but I'll show it as sitting in a Komprise hosted director. So it's hosted on the cloud in a hybrid SaaS solution.
So it's a virtual machine?
It's a virtual machine. So it's a virtual machine that can be spun up on premises. It's a virtual machine that's spun out of an AMI for us in Amazon. This is what provides the console that has all the nice pictures that the administrator uses. It also exposes an API for applications. So application scripts, they can use APIs and go after the data that's in the director. The director hosts the configuration. It holds the state that's used to make those pictures. And it's resident in, we'll just say that it's resident in the Komprise hosted cloud. On the premises, the component there is the observer. And the observer is a virtual machine spun up in ESX, or it can be spun up on bare metal or any other hypervisor as an install, as a typical Linux box install. And the configuration of the director, after the observer is connected to the director, the configuration that the administrator sets up in the director describes the storage. And now the observer goes off and discovers the storage that was configured. The observer should be pretty much co-located in the same data center with the storage to avoid high latencies. But once the observer is asked to discover the storage, then the administrator can choose to enable whatever shares they're interested in that we're.
Is there a one-to-one correspondence between observers and directors?
Not exactly, because as the size of the storage that needs to be analyzed gets larger, you actually can just scale up the number of observers by just adding another observer. So if you need, we recommend 2 for high availability whenever
scale
we're
out,
doing.
Not scale out.
Yes, it's scale out.
Scale out. It's a scale out architecture.
Yes, pure scale out. So new observers, they get added together, they work together as a grid, a cluster, and you'll see that when the transparent move technology applies, the grid of observers hosts an access address. And so they work very closely together, and as it scales, the machines can handle more and more shares, more and more files. So when the administrator enables a share, that starts analysis, where the observer goes into the share and starts looking at the files. And for each file that it finds, it produces an observation. And then that observation gets rolled up into what we call an aggregate. And that aggregate contains the multidimensional breakdown of all of the attributes, all the metadata of that file. And that's what's used to paint the pictures that you saw in the console. The usage graphs slices it up by access time, modify time, file type, user group, all of those are done in this aggregate. So we can handle billions of files over here and generate one aggregate per share. So it's a huge amount of insights gotten with a very scalable solution that the administrators see their shares and then dig into their shares.
How long does it take, pick a size and say how long it takes to analyze that?
So the speed we generally run is in the thousands of files per second.
So we have customers who have analyzed actually petabytes of data, multi-billion files in hours, basically, right? So, and I think one thing I want to highlight is, I know Mike talked about it, all this happens within minutes, right? So it's all, the service is deployed, customers deploy the observers, it's all software solution, there's no hardware involved, right? So VMs come up, you connect to the file server, and you see what Kumar showed as a green donut immediately, right? And the customers see the visibility of data immediately, and as we are scanning, we are refining that aggregate that Mike is talking about. So as the analysis finishes, you get the true picture of it, but within minutes, you can start seeing the value, you can start observing your data right away.
So this is Linux-based, right?
Yeah, so the observers are all Linux-based VMs.
So do they bring back every Linux file attribute that there is, or is there a subset of the attributes that it brings back?
They bring back everything they can see over NFS and SMB.
Okay.
Yeah.
In the performance for the time of that is tied to the number of files, not the size, right?
It's a number of files, absolutely.
Number of files.
It's all number of files,
Yep.
yeah. And one other thing to highlight, maybe you guys already noticed, there is no database here, right? So it's that's why it's completely scalable architecture, because a lot of the other solutions who were doing analysis, they had databases, right? The SQL database. And those were fine when you were at maybe, millions, right? But once you start talking billions, and not billions, multi-billions number of file, all these databases kind of fail.
Well, how are you storing your data then?
So we're not, and Mike, you want to probably talk about your aggregate magic.
Yeah, so we store it in these aggregates, which are our own customized format of putting this data together in cubes, but it is not a per file thing. So a share that has 100 million files does not have 100 million rows in the aggregate. The aggregates are exactly, once you have about 1 million files, the aggregate is completely full, and all we're doing is increasing the shares or the portions of the cubes that fill up based on the number of files and the size of files.
That data is stored on the observers?
It's stored in the director. So it's essentially we store them in flat files next to the director.
So what happens if on top of my on-premises storage, I start having some cloud storage, and more and more organizations are storing also on S3 or compatible kind of object store. So.
Yeah, so I think it's a great question, and that's why we've started, and what we have now is called cloud data management. It's really S3 data management and object store data management as well. And we'll cover, it's a similar architecture, but we'll cover in our third chalk talk about what we are doing for analyzing S3 data. We already support archiving to S3, which we'll talk about, but we're also adding much more analytics and cost analysis, especially for the data stored in the cloud and in the object stores, right? So the similar architecture, but in the cloud. I think Mike will expand to that as well.
That will be in the third.
In the third.
Chalk talk, and you can tell that the chalk talk go the different stages. I'll be using different colors. Okay. We're in the black color here.
So in terms of the metadata that you guys pick up, right, it's just the basic file attributes and so on, right? Can you actually customize those metadata and say, I just want it specifically for a certain set of metadata? Can you define those things?
We will get you everything that a stat of that file over NFS or SMB gets. Okay. And then if you want to, whatever you want to look at, you're free to do that.
Right, but if the file has some kind of headers and it's tied to some applications and some kind of compliance requirements.
Oh, so at this point so far, we do not dig into the file and open up that file and look at the content of that file and any metadata or tagging that's inside the file. It's something that can be added in the future.
Right, or you can actually have some kind of special connectors to some kind of applications and say that, okay, based on the connectors, I can pick up these files, right?
Exactly, exactly. Actually, there is a mechanism. So when I go into the next segment here, what you're describing could be done there.
Yeah.
Sure. Thanks.
So this is what paints that general picture. But I guess I'll just go right there now. The question you ask essentially is in a per file question. What is it if it isn't good enough? I mean, the picture that we give you and the analysis we give you, the metadata that we give you on the console is enough for you to figure out what you want to do as far as archiving. To build a plan out and to say how much can I save and then watch the archive go. how much do I save by doing this or doing that, and doing these what-if scenarios, and then actually activating them and working on them. But if I am more interested in the needle in the haystack, if I am more interested in digging into every single file, if I do need a database, if the customer comes to us and says, that's great, but I don't know, I want to know exactly what those files are. You give me a list of those files, and we hear that. For that, we have provided deep analytics. And deep analytics is that database that your fast analytics that we give you in minutes isn't.
Okay.
And so I'll show that right here, and as a deep analytics database or a deep analytics service. The user doesn't see it as a database. We abstract all that away. It's actually built on Elasticsearch cluster. You can host it on your premises, or you can have it, we run it as a cloud service.
So you can also, in the premises, I mean, government kind of customers that doesn't want to.
Yeah, they don't want,
the cloud,
because
okay.
It's all encrypted and secure, right? So we are encrypting everything we are storing. But some customers, obviously, for various reasons, compliance reasons or anything else, they want their metadata index to stay on premises, right? So
But
in that
anyway, every customer has a separate database. I mean,
they're all separated, right? There's no overlap, basically. Yeah.
Yep.
What about the security aspects of the file access and stuff like that? I mean, you have to have all the ACLs or whatever it is to require to access and understand what can be migrated and what can't, and that sort of thing? Or?
No, so deep analytics is not storing, is not involved in access. So none of the director or deep
just
analytics.
looking at the metadata, you don't have to have the security?
No, we do. When we move data, we get all the ACLs. We do store them, and I think we talk about analysis right now. Right? Once we go talk about our archiving, we'll talk about how we extract all the ACLs, we store it, and we honor all permissions, whether they're POSIX permissions, NTFS ACLs, NFS4 ACLs. We support all of them.
But
right?
you basically have to have root access to just even identify.
We do need admin access. That's right. Yeah, because we are for analysis also, because we are getting the metadata for files that we might not be owners, and also for move. Yeah.
I was going to say, how is this bundled? Is Deep Analytics, is that another add-on, or is that included in?
So it's included in the product now. Yeah.
And is the deep analytics, is it connected to the director? So if I'm a dark site,
if you're a dark site, your director is on your premises already.
Okay, gotcha.
And so your deep analytics will be next to it.
Yeah.
I mean, if you look at the tab there, it says Deep Analytics. You just click on that, and then you can go.
Yeah, I'll do the demo once when Mike talks about the architecture.
A couple more minutes I'll be showing here, and then we actually could show you the
how is licensed the product?
I'm sorry?
How is it licensed?
It's licensed based upon the capacity, right? So capacity based, yeah.
So if I am a genomic
Archive capacity or full capacity, or
with
Your capacity on the source, what we are analyzing, because and its licenses for the analysis, you can analyze that much, you can move that much, you can make a copy of that much data as well, and then obviously your different tiers of licenses.
Sorry to say that, but I think it could be unfair. I mean, it really depends on the kind of file that you are storing, because I could be an enterprise with billions of files, and I could be a genomic kind of organization that saves 1 gigabyte each file. So, and I have a lot of capacity.
Yeah, so I mean, I think just to keep it, our model is to keep licensing simpler, right? So if you go per file basis, it becomes very complicated. And honestly, we have analyzed all different verticals, right? And at the end of it, most of the verticals, they average out to, hey, you will have very big files and a lot of small files, most of them do. And you average out at, hey, one file is, on average, is 1 megabyte in size, on average, right? But you have more than 90% of your files which are smaller than 10K. And then there are few very big files, right? 10% of the files will be very big files. But generally, they average out to 1 megabyte. So keeping the license simple is the best thing. Otherwise, for us to be able to even charge, you have to first analyze the data. They don't know. Hey, they know how much data do they have, but they don't know how many files do they have, right? That's very hard to figure out.
Also, we give volume licensing for large customers, and we do provide enterprise licensing.
Yeah, so I think what Krishna said, we give volume licensing, so that everyone here in the video as well, volume licensing for large enterprises as well.
So a lot of these file servers nowadays have data reduction, like deduplication, compression, those sorts of things. You're talking about physical storage license?
It is the logical size that we see, but
Logical size.
Yeah.
logical size. But even if you start looking with the customers that we've looked at, what happens with the real dedupe and the real compression we see, it's like 10 or 15 or 20% at the best, and usually it's in the 5 to 10% range. That really isn't that big of a contributor on that side.
And really, our pricing becomes, not that of a debate with customers, because when they look at the value of how much data we will be moving, and that is 70% of their data that's going to go from their expensive storage to a cheaper storage like private object store or even public cloud. It's still, it is a millions of dollars of saving for them easily, right? That's what most of the customers see. And when we're talking about large enterprises, it's petabytes of data, and 70% of that is still a lot of data, and they say a big savings.
What about PCI compliance or HIPAA compliance for security? Because your ingesting machine has to have root access to everything, right?
Yeah.
So
It has to be the equivalent of a backup operator.
How do you okay, so backup operator.
Backup operator, that's
how
right.
you do it.
That's what we need, yeah.
Thank you.
Yeah.
So so that same observation that we use to generate the aggregates that you see in the director, that observation is sent to the Deep Analytics indexing service. And so this one really is the Deep Analytics built over Elasticsearch on multiple nodes for all of its redundancy that it needs, is that per file database, one record per file. And the director then can do queries. So essentially index with the observations, and then we query with the director. But beyond just queries, beyond just giving pictures at a per file basis and allowing you, and Mohit will show this, allowing you to slice down into much more granular details than we give you in the aggregate analysis, you also can tag the data. So you can classify the data. You can run a query and then tag that data that matches that query. This is for finding that needle in a haystack, that 1 million files out of 1 billion files that you're interested in because they match some set of characteristics. Then you can tag it to classify it, and now you can query on that tag. And even if the metadata that arrives later, and later analysis a year later comes through, that tag will still reside on that, and it follows that file no matter where we take it.
So the difference is, the first one's just basically doing an LS, grabbing all the LSLA and grabbing all the attributes, putting it up in the directory saying, look, this is all the stuff you got right now. Then if you dive in and use this one, it makes a database, and every line is the stuff that came from the original analysis unless you tag it and add more.
And then you add more, yeah.
And then my follow-up question is, and then if I run it again in a week or a month or whatever, does it append that record, or is there a second record, or how does that work?
It replaces the record
Okay.
with the new metadata, but it doesn't overwrite that tag.
Yeah. So tags are maintained. Yeah.
Okay, gotcha.
Yep. And not only can you tag just on a query, but you also can tag file by file. So let's say you've got an application that generates a log file every minute, because maybe it's watching a particular machine on a factory floor. I mean, not every minute, let's say every hour. So it creates a log file in your primary storage every hour, and that application knows characteristics about that hour that may not be true about other hours, or may not be identifiable from the metadata that it can put on the log file. It can actually say, call an API. So this app can call an API in Deep Analytics that says, tag this particular file with this particular set of data that I know from this hour, and I want that to follow the log file that I put in this data.
So you can, with the API, tell it to as files get created, tag it.
Yep,
Yeah.
exactly. So that data that we know right now isn't lost in the future.
How do file renames work in this structure? If I rename a file, do you recognize the fact that it was renamed with the original name, or?
So if you rename the file on the source, you're saying? So the next time we analyze, I think it's really used for, hey, this is my project. I'm done with my project. I'm going to tag those projects, and I'm going to keep it like that, and then you tag that project. But in the renames, if you're going to rescan it, we won't we won't apply those tags because we're not really, what we don't want to do is, and that we always believe in, we don't want to touch your data, right? We don't want to modify anything on your data, so we are keeping the tags outside in our index rather than on the data itself.
So you want to?
Yeah, I can do a quick demo about it now. So right in the director, as we were seeing, Kumar showed the plan page. Just right next to it is the deep analytics, where this one kind of shows all the detailed analytics about your data, and you can filter by whatever you want. In this case, we're looking at again all data view. You can view by last access, last modified, and what you here on the left you see is all the filters that you can apply, right? So you can really search for. If you're looking for a particular project, right, you can just search for, hey, directory, and generally you put the project files in either the file name and you have the directory path. So you can search for that project name in the directory path itself. So you can filter and you can say, hey, it contains a particular value. You can run it and it will filter all the data and only show that information, right? More than that, you want to see the list of files. Here you can see a sample set of 1,000 files. You can expand to it, and we'll show you a sample set of 1,000 files in here. But if you want to get more, you can either download the report that will give you more data, but we have an API where you can just get all the files you want, right? So it gives you it as a JSON object, and you can just, hey, I want 10,000 at a time. You can just get it till you want to do something with it, right?
So in this case, the top 1,000 files would be by size or by last access, whatever you're sorting on.
Yeah, this is by size. Yeah. So you can get it. You can get it the way you want.
By server, and I'm thinking that would be like really great when you're trying to investigate a breach.
A particular server?
Yeah.
So you can filter a particular server, you can filter a particular share within a server.
Refresh or something like that.
Yeah.
Well, I was thinking like if you get a breach, somebody's put a rootkit someplace and you can kind of trace back by
which files. Yeah, so you can filter by a particular server, particular share, particular owner, files owned by zombie users. Hey, you can find those files right away. We have customers, hey, I want to find all my PST files that the users are creating, which are more than particular size. They're taking a lot of usage, and also PST files owned by zombie users, right? I want to delete them. That was a use case one of our customers kind of were using it for. So there's a lot of use cases that you can use this for.
Can you mass delete? Let's say, I don't know, someone's doing an MP3 library.
Yeah, so we have a confine capability in the product where you can, we don't ever delete the data, but it confines to a trash folder that you can go and kind of delete.
And all of that you can use through the API too, right?
Everything you see in the product, as Mike showed over there as well, is driven through API, can be driven through API. They're all REST APIs that you can drive it. And our customers use it that way as well. Right? They use the console, but if they want to automate in their workflow, they leverage our APIs.
In fact, many of our customers, that was very critical to them. They have some homegrown management system. They are using this to integrate that and enhance what they can do.
The same thing here, you can see, if you want to look at the other graphs as well, you can just go down and you can see by top shares, top file servers, all the same information as you had in the other.
So if files get archived into the trash folder and then someone goes in and manually deletes that, is there a record of that in there?
So we would have a record of what we put in the trash folder, but if they delete it, no, we're not tracking that. Yeah. So we would have all the audits of what we are doing.
But you would have a record that the file existed and then the file is gone.
We will have the record the file existed on the source and we moved it to the trash folder. But we won't have a record of if they delete it from the trash folder because they are doing it themselves.
And we no longer analyze that trash folder. That's been taken away.
Yeah. Right.
Okay. So now we've got this nice deep analytics to give you those deeper insights. And one of the great things we can do with this, now that this is a separate world connected by the director, let's say you have another site. And that other site, you put a grid of observers, and it's got its own storage. Those observations also will go into the same deep analytics index for you as the customer. So now you have essentially a global metadata lake of all your shares, NFS, SMB, whatever the vendor is, NetApp, EMC, Windows, all of that will now be retained in a global metadata lake. So you can do enterprise-wide searches and find the data that you need to find anywhere around your entire global enterprise.
So, you're constantly scanning every file share in the system. I mean, how much overhead is that? I mean, how does it impact the file services and stuff like that?
It does not impact. I think there are two reasons, right? First of all, we are adaptive, right? I think Kumar mentioned that we slow down if we do see any impact on the performance. And then the second is, I think the file servers that we're talking about these days, the metadata are generally cached heavily. So it's not really hitting the file servers. And we have scanned multi-billion files. And I think all the customers, I think one of the customers were like, we want to deploy you into the production because a lot of time our products come in, they cannot scan the production file servers for different reasons. And they deployed right in the production data that we scanned. And there was less than, I would say generally is less than 3% overhead, even less than that we generally see. And users notice nothing as we are analyzing the data. We have never, and we have customers over 85 petabytes of data. They have, I think around 100 billion files probably, and they have had no issues with us analyzing their data. Right.
So there's a couple of questions.
Yeah.
One is, do you provide any global search functionality? Is it like a self-service? Google-like, so I want to search as a user, okay? Granted that I have the rights to do it,
yeah.
So across all my organization. So for a file, for a name file, for a specific type of files, and things like that.
So based on metadata or based on content?
Right. So first, this is the first question.
Okay.
The second question, yes. Are you planning to provide any full text indexing so that I can do full text searches across?
So I think your first question is, okay, is the user-based searching kind of allowed? So right now you can search anything. So it's generally for admins, but that's something we're absolutely going to add, where based upon what access do they have, they only see those results. Right, so that's something.
Enterprise Google search.
Exactly. So they can just it's more for generally what use case we are hearing is more for your department. Generally we have large IT organizations, but they have different sub departments IT, and our product is being deployed by the overall IT department. And now these sub IT groups, or IT admins, they want to search. But they want to have one cluster. They don't want to manage multiple deployments of Komprise. They want to have one deployment of Komprise, but then this individual sub-admins, they can search the data, but they only get the results that they have access to. Right? So that's absolutely, that's kind of is similar lines of what you're asking. Maybe not necessarily every user is searching, more like your sub admins are searching. That's definitely that we are doing. The second question is full text search. That's something we have discussed, but it's could be we might do, but I don't think so. Right now we have plans to do that.
But architecturally it allows.
It allows you.
But it is something that, I mean, if you had your application here, did a query, pulled back all of the files that match something, say you have some tool that will go over PST files and find out if this data, if that email has compliance problems in it, for instance, then you can write a little content manager, and that it says, hey, please query all the data that matches some interesting set of filters, and I'll bring it back here. I, as the content manager, will then go open those files, look at them, or look at the headers, and then the content manager can then generate tags that the application can then tag right back on that data. So you can you can develop your own content management or internal indexing if you want.
That's pretty powerful. I mean, that just seems pretty powerful to me, especially if you could add the ability to do that and restrict what just individual users were able to see.
Yeah.
if you think about, for marketing departments or
Yes.
things like that, trying to find files, it would be just
Yep.
crazy useful.
I'm going to dive a little bit deeper about the threshold to make sure that you know you're not impacting production. What triggers the threshold to say, hey, this is causing a problem? How do you know what feedback loop is involved there?
So when we start a file, we know how long it takes generally, right? When we have no load in the system. But as we keep starting and the load increases, we know, hey, the response is becoming slower, right? So we slow down based upon that, right? That's
Automatically, you throttle back.
we throttle back, yeah. That's right.
And that throttle can be set by the
Yeah.
administrator. They can go and say the analysis throttle. We run at 100% because we never hear this.
We never hear this, right? And to be honest, and we have scanned, I think overall, if you talk about hundreds and hundreds of petabytes of data across our customers, and we have never, ever had a customer complain about, hey, you guys are too fast and bringing our system down. Never.
Okay, and targets, different? Are you going to deep dive into the target varieties?
Yeah.
Yeah, we can go into target varieties. I was just going to show one target, but that actually is a great segue because that's the next topic.
Yeah.
Talk 3.
Yeah, chocolate 2.
Let's change colors here.
We still are number 1, right, Mike?
Yeah, this is still the